Alright, so finishing these first pages of notes. This one we're going to go backwards. We're going to find, well, we'll see what we're trying to find. You want $5,000 in 3 years in a new account that pays 3% interest compounded quarterly. So how much should you start with initially? So we're trying to find the initial amount, which is, if you recall from up here, P. So we want there to be $5,000 in the accounts. But how much do we have to start with in an account that pays 3% interest compounded quarterly, 4 times a year, raised to the 4 times, and we're doing this for 3 years. So in other words, it's to the 12th power. So a couple of ways to do this. The first way, tell you what, whenever you're in doubt and you're like, I'm not sure how I'm going to solve this, pull out your calculator. Your calculator can solve anything you want. Let me show you how. Go to y equals, and if you got anything there, clear it out. You put in the left side of the equation. We want 5,000. Oops, that's too many thousands. And then the right side of the equation, we got x times parentheses 1 plus 0.03 divided by 4 raised to the 12th. I'm going to keep so we don't got to put in parentheses, just put in raised to 12th power. And I'm going to zoom 6 it, make sure we all start here, and there's something. But that's all I see. Where's the other thing? Well, Smith, we got to get up to 5,000. All right. So let's go to our window, and our y maximum is going to have to be a lot bigger. Let's make it 6,000 just to make sure we see it. And then press graph. Still don't see it. Well, why don't we see it? Well, here's the thing. Now we see our 5,000, and we saw this at first, but now we don't see it. Now remember, we're trying to find P. And how much money do we have to start with in order to get to $5,000? Probably got to start with more than just $10 here, right? Probably got to start with, well, we want to get to 5,000, so it's probably less than 5,000. But I'll tell you what, let's make our X maximum 5,000. And hopefully we should see, see, now they're going to go and cross. Right there is our solution. So we got to figure out what our P is going to be. So we're going to go to our calc menu. We're going to find the intersect. And this one is simple enough where you can just go enter, enter, enter. And here's the thing. If we want $5,000 in 3 years, we have to start with $4,571.19. We have to start with $4,571.19. You ever heard the expression, it takes money to make money? There it is there. You start with a little bit of money. It's going to take a long time for it to grow. Anyways, that's the hard way, really. We had to think about how to make the graph show up and everything else. Here's the other way. What we got here is 5,000 equals P times. Now this whole thing can be put in our calculator, right? Check it out. Let's go to our home screen. Parentheses 1 plus 0.03 divided by 4 to the 12th power. Oh my goodness. Sorry, y'all. 1 plus 0.03 divided by 4. Where's the 4? Raised to the 12th power. And what we got here is 1.0938. So what we got here is P times this constant. So we can do 5,000 divided by our answer here. So do 5,000 divided by our previous answer, and we get $4,571.19, just like we said. So, two ways to solve this problem, guys. If you're ever not sure how to solve something, use a graph. Also, let's talk more about what's happening here. I kind of feel like I glossed it when we were talking about it here. So here's what's up. Here, let's say we start our new account in January. We get our $2,000, and then a year later, they're going to say, "Would you like some interest, Smith?" And you're like, "Yeah, why not?" So they're going to give me 6% after 1 year, and then they'll take that bigger amount, that's 6% of 2,000, which is like, what is 6% of 2,000? That's right. It is $120, right? And then they'll give me another 6% at the end of the next year and 6% at the end of the next year. Where here, quarterly, here, if we start in January, let's say, at the end of March, they'll say, "Hey, Smith, do you want a little bit of that interest that we said that we'd give you? We'll give you 1/4 of the 6% on your 2,000." And you're like, "That sounds great." So they'll give you a fourth of 6%. So you'll get a little bit of money in April. Then July comes around, the end of June, or the end of July, I should say. And they'll say, "Hey, you want a little bit more?" So they'll give you another quarter on your already slightly more than 2,000. So they have a little bit more. And at the end of the first year, rather than having here, if you remember here at the end of 1 year, we had $2,120. But in the other one, if we did it quarterly, it would be we would have $2,122.73. We'd have a little bit more. This is after 1 year. So they'll give you a little bit more if you compound it quarterly. Here we're getting a piece of the interest every month. So 12 times throughout the year, you're going to make this grow a little bit faster. Right? So that's why you want your things compounded more often. Think about this. We'll talk about this later, but what would happen if they compounded your interest not just daily, but every hour? Or what if they did it every second? Yeah, some stuff to think about. Smith out!